Our topic today is binomial theorem validity. Binomial theorem is 1 plus x power n is equal to 1 plus nx plus n into n minus 1 over 2 factorial x square plus n into n minus 1 over into n minus 2 over 3 factorial into x cube and so on, where n belongs to the real numbers. Now, where it belongs to the real numbers, then it has all values. Now, first of all, we will take for the validity when n belongs to a positive integer there. So when it belongs to a positive integer, we know that the total terms in the binomial expansions are always finite terms. So it is valid for every value of x, whatever you put in that, but n should belongs to what? A positive integer. For example, 1 plus x power 3 will become 1 plus 3x plus 3x square plus x cube. Total terms are there 4, and we see that every value of x you can put into this for this binomial expansion there. So when n belongs to the positive integer, then it is valid for every value of x there. But if n belongs to the real number, but n should not belongs to the positive integer, then we know that they will have infinite terms in that expansion there. Now we have to verify the validity for that binomial expansion there. Remember one thing, first of all, that for the validity of this binomial expansion, when it is not positive integer but the real number, then x modulus should always be less than 1 for that validity there. This will become x greater than minus 1 less than 1 for its validity. Now we take the separate examples for this case there. 1 plus 4x power minus 2 there. So minus 2 is indicating that it is not a positive integer, but it is a real number. And x value is basically equal to 4x. So 4x modulus should always be less than 1. This will become 4 modulus into x modulus less than 1. 4 modulus is 4. So x modulus is less than 1 by 4, or x value will be greater than minus 1 by 4 less than 1 by 4, or this is the answer for this part there. Now, you take the second example, 1 minus 3x power minus 1 over 2 there. Here x will be equal to minus 3x. So that should be less than 1, or minus 3 modulus into x modulus is less than 1. Minus 3 modulus is 3. So x modulus is less than 1 over 3, or x is greater than minus 1 over 3 less than 1 over 3 there. Suppose we have given 4 plus x square root, which will become 4 plus x power half there. Now, it is not the standard form of this 1 plus x power n. So you will make it in the form of this 1 plus x power n. So this will become 4 power half into 1 plus x over 4 power half. So this will become 2 into 1 plus x over 4 power half. Here x value is basically equal to x over 4 there. So you can write this thing at x over 4 modulus is less than 1, or x modulus is less than 4, or x will be greater than minus 4 less than 4 for this answer there. Suppose we have another example, 8 plus x whole cubic root. We can write this thing as 8 plus x power 1 over 3, or you can write this thing as 8 power 1 over 3 1 plus x over 8 power 1 over 3. This will become 2 into 1 plus x over 8 power 1 over 3. Here x will be equal to what? X over 8. Modulus should be less than 1. Our x modulus is less than 8. Our x is greater than minus 8 less x is greater than minus 8 and less than 8 is the answer of this portion there. Suppose we have another example, 1 over 2 plus x square root, which we can write this thing as 2 plus x power minus half. Or you can take 2 common there, 1 plus x over 2 whole power minus half. Or this will be 2 power minus half into 1 plus x over 2 power minus half. This is your x value there. So x over 2 modulus is less than 1. Our x modulus is less than 2. Our x is greater than minus 2, less than 2 after the verification of this modulus function significance there. Suppose you have sixth example for this portion, 1 over 8 plus x whole cubic root, which can be written as 1 plus 8 plus x power 1 over 3 here. Or it will be written as 8 plus x power minus 1 over 3. Or if 8 is common, 1 plus x over 8 whole power minus 1 over 3. This will become 2 power 3 power minus 1 over 3 into 1 plus x over 8 power minus 1 over 3. Now your x value is what? X over 8 there. So x over 8 modulus is less than 1, or x modulus is less than 8, or x value will be greater than minus 8, less than 8 there. So these are the few examples we have taken it from this binomial theorem and for its expansion, where we know that whenever n belongs to the real number but not a positive integer, then its validity will be with the x modulus less than 1. We can use this property and we can find out the range of that modulus function there.